In this video we work another problem that is a uniform acceleration. The ball is thrown upwards with a speed of 10 meters per second. A cliff 40 meters above the ocean. The ball goes up, then the ball comes down and eventually splashes into the ocean here some later time. This is a free fall type problem, and so we know that the acceleration in this problem based on my axis is minus g, or minus 9.8 meters per second squared, and it's constant in the problem. We do not know the time that it takes the ball to splash. We were told that the ball started 40 meters above the ocean, and I chose the ocean as my reference point. Not that you had to do that, but that was my choice. So that means the initial position of the ball was 40 meters. The final location at the splashes is 0 meters. The initial speed was upward, which is positive y, at 10 meters per second. Remember that we stopped the problem just before it hits the water. So it has a downward velocity. It's not 0, because we cannot include hitting the water and still say the acceleration for all time was 9.8. We're only including the push and pull of gravity in free fall problems. So we do not know the velocity right before it hit the water. These are the things, again, only two unknowns. We had 3 equations. We could simplify the equations a little bit, as I've done in other videos. This is 0. This one, there's nothing that I can get rid of. This one, I can only get rid of this final position is 0. I could rewrite this, but let's first look to see what we need to find. We are asked how long. That means the time. This equation and this equation are the only two that has time, so that's where we're going to start. Do we know y? Yes. Do we know y not? Yes. Do we know v y not? Yes. Do we know t? No. Do we know 1/2? No. Do we know ay? Yes. Only one unknown in this equation, so this is the best and quickest way to solve it. The problem with this equation is it's second order. It has a square. It's a parabola. And that means that your algebraic skills are going to need to be able to solve things that are second order. They're going to have to solve parabolas. To do that, you got to remember the quadratic formula. So I remind you that this equation, which can be written as this, 1/2 times minus g times t squared plus vy naught t plus y naught equals 0 is of the form of a t squared plus bt plus c equals 0. T, by the quadratic formula, is minus b plus or minus the square root of b squared minus 4ac over 2a, and I expect you to know that. Alright, 2 things we can solve. We can solve straight lines easy, and we can solve quadratics. This is parabolas. There are formulas for the cubic and the quartic, and that's it. After that, there's none. So these are the ones that we should be able to solve. That's what makes this problem harder, is because here you're going to have to be able to solve this quadratic equation. So if we're doing that, let's sit here and see what we can do about this. And by the way, I should say that I might be able, because I'm lucky, sometimes if this is y not had been 0, we might be able to simplify this. It's not the case here. So my solution should be t is equal, well, b, that's this term right here. That's minus vy naught plus or minus the square root vy naught squared minus 4 times minus 1/2 g times c, which is y naught, all of that over minus 2 times minus 1/2 g. Well, we can simplify that a little bit. T, the 2.5 makes just minus g. Minus g over this is vy naught over g. So we have a term here. I've got minus g. That flips this to a minus plus vy naught squared. Minus and minus makes a plus. 2g y naught over g. Now here's the thing that I want to look at. This term will be positive. This term that we're going to be adding or subtracted, this is positive, but it's going to be bigger than vy naught over g, because if this was 0, this would be the square root of vy naught squared, which would give vy naught over g, but we're adding something. So this numerator is bigger than vy naught. If we subtract, we're going to end up with a negative time. I'm going to do that, but then I want to talk about when you come up with one of these negative times, because in our case, that is not a possible solution. The ball was thrown at t equals 0. So why did it show up in the math? Well, it's called an extraneous solution, and it has a very good reason for showing up in the math. So let me put in some numbers. You have 10 meters per second over 9.8 meters per second squared. Meters per second over meters per second squared gives you a second, so units make sense. Over here I have 10 meters per second squared plus 2 times 9.8 meters per second squared times 40 meters. So again, I look at this. Meters per second squared times a meter is a meter squared per second squared, same as it is over here. Square root of that is a meter per second, same as it was over here. That makes all sense. Units are checking out. If they don't check out, I stop right then and fix, because I must have made an algebra mistake. It does me no good to spend and go trudging along for 15 minutes only to find out I've wasted my time because my equation was wrong 3 or 4 lines back. We now push these in a calculator. This is a little bit more than 1. It turns out that if you punch in a calculator, this is a little bit more like 3 seconds. And so you're going to get 2 answers. The first one is minus 2.01, I think it is. I had to check that. I believe that's correct. And the other one, or if you take the plus, is 4.05 seconds. Now, this can't be right. The time cannot be less than 0. This, therefore, is the answer. It takes 4.05 seconds for it to splash down. The ball was thrown up at 0. It's got to be at a time later than that. But why did we ever get this weird answer? How did the math mess up? The math did not mess up. The math did exactly what we told the math to do. So if you were plotting time and you were plotting the height of the ball y, what you would find is that the ball went something like this. And there's the answer at the time that we wanted, right there at 4.05 seconds. And when the ball was right here, this was 40 meters. That was 0. But when you wrote the equation up before, when you wrote this equation here, math didn't know that you meant to not make it a parabola, that you meant to truncate it. Math says the parabola goes on forever. So when you said, when was it at 0, it said, well, there and also here. The fact that this part never existed because we didn't throw it, the math does not know. This extra time, this negative time that we got over here, is called an extraneous solution. Often when solving a problem, you may have extraneous solutions because of the way you did the math. You must use your physics knowledge and your understanding of the problem when you have one of those to eliminate it. All right? It is not a real physical problem to the thing. Something else, since you're going to deal with this parabola type equation, note that if you'd have taken, say, this point right here as the time, when was it 50 meters, for instance, you might have got 2 solutions. That's because you would have been allowed to add and subtract. This number would have been less than this term here, and so if this was 1, maybe this was 0.2, so you could have subtracted 0.2 from 1 and got 0.8 seconds, and you could have got another time. You could have done it up to here, but at some point right here, when it reached its maximum height, there is a time where there's only one solution. Well, what happens is that time occurs when you end up with one of these things where the final time is 0. Now, we don't show it here because remember, I simplified this equation. I got rid of a y that was 0. Normally, it's y minus y on this term, and if this term happens to be such that this is negative and is equal to this, then this whole thing will go away and you'll only get one solution. So I just tell you something else. The time at which it was at its maximum height is Vy naught over G. This is something you should have learned in college algebra back, or algebra 2 in high school, about parabolas. That when this thing is the only term, that's when the object is height. What if I said, when does it get to this height? It never gets to that height. How does that show up in the physics and in the math? Well, in the physics, it just doesn't get there. In the math, what happens is this term is more negative than that term. And so you get the square root of a negative number, and you get imaginary solutions. Imaginary solutions mean in your dreams. So if this square root turned out to be a negative inside that square root, then you would end up not having solutions. Because of these things are so important, this b squared minus 4ac is called the discriminant. Three possible solutions. If that discriminant is greater than 0, you get 2 real roots. If it's 0, you get 1 real root, which is your time of maximum. And if it's less than 0, they're imaginary. Play around and make sure you really understand the quadratic formula. Make sure you really understand the algebra here that you've covered in the past, because we're going to run into a lot of times when you have to solve parabolas. And you need to know and be good at them, so anytime you run into them, you can concentrate on the physics and you're not worried about how do I solve the parabola. All right, that's it for this problem.